Hi there, I'm Hao. It is just another video of me solving a numerical problem. So we have an array of citation here where the citation I is the number of citation researcher received for the I paper. So it is the paper number, and it is the number of citation. The value going to be the number of citation. So we need to return the H index, right? We need the maximum H index such that the given researcher had published at least H paper that have been cited at least H time. So if we look at the example here, right? Our index would be 0, 1, 2, 3, and 2, 3, and 4, right? So the H index gonna be we want the maximum H index, right? So the maximum gonna be 5, right? Is there at least 5 paper with a citation of greater than or equal to 5, right? Which is no, we only have 6 and 5, right? What about 4? Is there 4 paper with a minimum of 4 citation? No, only 2. Is there at least 3 paper with a minimum of 3 citation, right? Yes, it is 3, 6, and 5, right? Right. So if we do it like this, so hash here would be our length of the array, right? And we need to iterate through it again to count how many valid input, right? Valid paper, so that it opens where, so it is not very efficient. So what if our array, our citation number is sorted, right? So if we sort the citation, we're gonna have 6, 5, 3, 1, and 0. So this would be our index. So because it is sorted in descending order, right? So because okay, it is the paper, right? The paper number, right? But the index is the paper is 0 base, right? 0 base, but the hash index is one base, right? Because is there at least 1 paper, there are at least 2 paper, right? So is it gonna be the index plus 1, right? So if it is something at index 0, okay, we have hash equal to 1, right? Right. If we stop here, we know hash is equal to 2, right? So on and so forth. So this is the hash value, right? Gonna be 1, 2, 3, 4, and 5, right? So on and so forth. Okay. And yeah, because it is sorted in this descending order, right? Uh, it's always we can always take advantage of whatever come previously, right? So for example, if we look at the first element, right, which is hash index is 1, right? Index plus 1, remember, is 1. Okay, so if there at least 1 paper, right, with a valid value, is there at least 1 paper with a minimum number of 1 citation, of course, right? So we can just compare the value here, right? The 6 is greater than 1. So yes, we have hash equal to 1. So we go to the next one, right? 5. So now we have hash equal to 2, right? Because we're at index 1, right? Because we are at index 1, we know that whatever come before 1, which is 0, right? Because hash is 2 here, right? We know whatever on the left side is already valid, right? Because hash is growing, right? So if hash is 2 here, which means um, if hash is 2 here, then there will be so if this number is valid, right? If 5 is greater than 2, right? Because hash is 2, then it means that there will be at least 2 paper with the minimum of 2 citation, right? Because 5 is valid, right? So whatever comes before 5 is also valid because we are sorted in descending or order, right? So we can take advantage of what already happened in the front here because the array is already sorted in reverse order, right? So here hash is 2 because we are at index 1. Hash is 2 here, right? If 5 is valid, which means we are good, right? We have at least 2 papers, right? At least 2 papers with the minimum number of 2 citation, right? Because 5 is valid, right? So whatever comes before 5 is also valid. So we look at the next one. Next one hash is 3, right? So we only compare like this number right here. So now hash is 3, right? Which means we need the current citation, current number of citation, right, to be at least 3, and it is at least 3, right? At least 3. So it is valid, right? So because it is 3, whatever come before it gonna be greater than or equal to 3. So we know it is valid, right? So we just keep going, right? So now we are at hash equal to 4, right? So is there at least 4 paper with a minimum of 4 citation? No, right? Because we are at the number 4. We're looking at the fourth element, which means we are looking at the third index, right? We're looking at the fourth element, which is we are looking at index 3, right? So only 3 elements come before it, right? Because we are at the fourth element. So whatever come before gonna be a 3, right? The total number of elements before the fourth element is gonna be 3 elements, right? So if this element is valid, then everything before it will be valid because everything before it is larger. But if this element is not valid, right, we can just short circuit and return the index. So 1 is less than 4 here, right? So yes, we don't have 4 paper with at least 4 citation, right? So because we stop here, we can just return the index, right? So luckily, because the index is 0 base, right? So wherever we stop, we can just directly return the index, right? With reflecting the hash value. Okay. So that code is up. So I wanna sort the array first, citation, and we're gonna sort it in a reverse order. So we're gonna have index, right? Okay, 0. So why the citation of index, right? Is so why the index, right? Sorry. Uh, um, what is it? So what are we comparing? We are comparing the index, right? The value, okay, yeah. The value at the index, which is the number of citation, have to be greater than the index. Index plus, or you can just return the index at the end. Right. So we are comparing the value, right, to the index. The value to the index, right? 3 is greater than 2, right? One is smaller than 4, right? So which means like why the index, right? Sorry, why the value, right? Why the value is greater than the index, right? 5 greater than 1, 6 greater than 0, 3 greater than 2, right? And then 1 greater than 3, which is false, right? So we just stop. So while it is greater than, we just keep going to find our larger hash number. And then where will we stop? We're just gonna return the index. And it worked. Thank you for watching.